Hey everyone, welcome back to the channel. In the last video, we dived into the basics of .NET Aspire, giving you a high-level overview of what it is and why it's useful. We talked about its key features and why it's becoming a popular choice for developers looking for a more streamlined and modular way to build applications. If you haven't watched that video yet, I highly recommend checking it out before continuing with this one. In that introduction, we covered essential concepts that will help you better understand what we are going to dive into today. You will find the link to that video right up here in the top right corner. Make sure to watch it first if you are new to .NET Aspire. Before we dive in, if you find this content helpful, don't forget to like the video, subscribe to the channel and hit the bell icon so you never miss an update. Your support helps me create more videos like this to help you on your development journey. Now in today's video, we are going to move past the theory and jump into the practical side. I'll be showing you exactly how to create a .NET Aspire project from scratch and how to integrate it into real-world applications. We will go through the step-by-step process of setting it up, discussing the structure, the components, and how you can leverage its capabilities to enhance your development workflow. We will also explore real scenarios where .NET Aspire shines, like organizing code better and promoting clean and maintainable solutions. By the end of this video, you'll not only understand how to set up .NET Aspire, but also how to start using it in your day-to-day projects to improve productivity and build more scalable applications. By the way, if you are interested in checking out these projects, they're hosted on my GitHub account. However, it's currently a private repository. If you'd like access to clone the application, just drop a comment below this video and send me your GitHub username. I'll be happy to grant you access so you can explore the code and see how everything is put together. So stick around because today's content is going to get hands-on and actionable, helping you take your understanding of .NET Aspire to the next level. Let's get it started. Alright, here we go. Let's head over to Visual Studio and take a look at our demo application. Now this is a small app called My Weather Hub. In this case, we are using the United States National Weather Service, NWS, which provides a publicly accessible API at api.weather.gov. If you check out the GitHub repository, you'll find links to this API, which you can use to get real weather data for location across the US for our demo. We created a method to fetch weather forecast using HTTP client. You might already be familiar with adding an HTTP client in your web applications, and we are doing something similar here. This client connects to api.weather.gov, but one of requirement from the NWS API is that we must provide a user agent. So we set ours to Microsoft.NET Aspire demo. Once the client is set up, it makes requests to get a list of weather observation station across the US from there. We can choose a station and make a second query to get the forecast for the location. Now let me show you the simple demo. On the left side of the screen, I'm using Blazor's quick grid to display a list of weather stations. On the right, there is some text that explains the app, gives a link to the National Weather Service and shows information about a couple of locations. This is helpful for those who might not be familiar with US geography and want to explore different places. There is quite a bit of data here, and I can quickly scroll through the list of observation across various states. Let me search for a station which is just outside Philadelphia. When I select the Philadelphia station, I get the current weather forecast for that location. Now, keep in mind, since this is US based data, all temperatures are in Fahrenheit. Since this is live data, I can change the location and look at the weather for Manhattan, New York. When I do that, I see similar weather conditions for Manhattan. You can also play around with this and try out the sample data yourself. The API is publicly available, so feel free to explore different locations. Let's now search for Juneau, Alaska. You'll notice that as I switch between locations, the app makes requests to weather service, retrieves the data and displays it on my ASP.NET web server. This is all done on the server side and the data is fetched live. Let's try another location, Arizona, for example. But here I've deliberately thrown an exception in the code to demonstrate how the app handles error. When you query weather stations across the US, there may be times when a location fails to respond. For instance, Arizona could be experiencing a sandstorm and the weather station might not be able to send data. In that case, the API could return an error, and we need to handle that gracefully. While it's not a great experience for the user, I can simply say go ahead, click another location and try again later, hoping that the connection will succeed on the next attempt. But as a developer, I know this is a problem we should address. Now this is a small demo app that I'm running for myself. If it encounters an error, I can just hit F5 to refresh the page. However, if this weather service was meant for a larger audience, we'd need to improve the experience. So while it's fine for a small app, at some point you'll want to make it more reliable and user friendly. uh, let's say I go back and look at the logs for this application. Since it's just me running it, I can easily find where the error occurred and fix it. But that's not practical in a larger environment. When you start scaling up an app, you need to handle errors properly and ensure that app is resilient. So let's talk about how we can make improvements. One thing we want to introduce into this app is smart defaults, features that will improve observability, resilience, and health checks. These features are already available as NuGet packages or as part of the base class library in .NET. You can configure them manually or take advantage of .NET Aspire, which provides a smart default with just a few lines of code. For example, let's start with OpenTelemetry. OpenTelemetry is an open source standard for collecting metrics, logs, and traces from your application. In ASP.NET Core, OpenTelemetry is tightly integrated with the logging services and metrics system. You can add a few lines of code to configure it yourself, but with .NET Aspire, you can enable it with just one line of code. It even sets up exporters for services like Prometheus, Azure Monitor, or third-party systems. The next thing I want to talk about, of course, is resiliency. Resiliency means retrying within a reasonable time span so that if there is a problem with the connection, we can retry and attempt to get the data or connection. We need to present a good experience. There's a standard resilience handler built into the framework as part of a NuGet package you can install. This handler uses a standard resiliency timeout to retry requests when an error occurs. It also includes sensible back-office strategies, ensuring continued attempts without overwhelming or causing issues with the service. These defaults were selected by the ASP.NET team as sensible options, but you can tweak the timing and capabilities to better fit your application's specific needs. Another important feature is health checks. These allow external systems like Azure Front Door or Kubernetes to monitor your app and ensure it's running correctly. If your app encounters issues, these systems can route traffic away from it or restart instances as needed. Adding health check is simple, and with smart defaults, you can have them up and running quickly. So I'll head back over to Visual Studio, and this is where we get into some live coding. I'll go up to File, then select my recent projects and solutions. You'll see there's a folder in the repository called Start with API. This is the second step in the process where we have taken the interaction with the National Weather Service and placed it into an API project, which you can see here. It includes the NWS manager, which is the same as before, but we've copied it into this new folder so it knows how to communicate with api.weather.gov. We've moved everything over to this project, configuring it with a bit of minimal API. As you can see, we have map API endpoints, and we've enabled output caching to store some results in memory. I also have an endpoint called Get Zones, which is exposed through OpenAPI, and another called Get Forecast by Zone, which expects a zone ID. This allows our application to fetch forecasts by zone. Now our application needs to know where that API is running so it can connect and retrieve data. In the Blazor app for my Weather Hub website, which users will connect to the app, it does the same add HTTP client logic. It reads the configuration file to find the API endpoint to connect to. I also have the NWS manager here, but now it uses HTTP client to interact with those endpoints from the API we just exposed. By wrapping our interaction with the weather service API, if we want to switch to a different service or geography later, we can easily update the API endpoint and the weather hub app will still function as expected. Since there are now two parts to this, my API project and my website, I need to run both. When I start the application, it will launch two websites, one for the API and one for the weather hub site with a rich user interface. And now when I search for Los Angeles weather, it fetches and returns the data without issues. But services are running and communicating with each other. But I had to manually configure where things were located. We will dive deeper into this configuration soon, but for now let's try searching for weather in New York. You'll see the same process works, but I encountered an error. Because multiple websites are running, I need to check logs in different places. I found the error in my website logs, but correlating it with the API logs isn't easy. This is where introducing smart defaults and observability will help smooth over these scenarios, making it easier to read and coordinate the data. Now I'm using Visual Studio here in Windows. You are going to be able to do the same thing at the command line with the .NET tools if you are on Mac or Linux. These templates are available for you as well. I'm gonna add a new project to my solution, and the project we are going to add here, it comes. I'll filter for my Aspire projects. We are going to add the .NET Aspire service defaults. So this is what contains those smart defaults that we are going to add into our application, and I'm just going to call this service defaults. You see a little service defaults project pops up down here, okay, and inside here we have a series of extension methods that include those features we just talked about for observability, for resilience, and for manageability. So we see here add service defaults. We have this entry point that configures OpenTelemetry, configures health checks, and configures service discovery, as well as HTTP client defaults. So I can now use this, and you are welcome to scroll down and see how those are configured in this file. But I can now include this inside both other projects, and they will know how to use that service default and those smart defaults inside their websites. Now you can actually drag this project onto the other projects, and in Visual Studio it will add that project reference for you just by dragging it. You don't have to right click and go all the way through the add project reference. Now I need to make sure that my application knows to use those smart defaults, so I'm going to go into program.cs for the API, and I'm going to add those service defaults. So I'll just go up here and say builder.add service defaults. I'm going to grab that statement because I want to do the exact same thing over in my website. So I'll just add it right there to add those service defaults. So my website can do the same things as my API and have those telemetry, the health checks, and resiliency. And that's it. I added two lines, one to each of my two projects. I'll start this again, and it will start the two websites, one for the API, one for the Blazor project. And now we are going to start to see how immediately our project is improved and able to connect these. So here's my weather application running, and I can click through and start interacting with some of these. And there is some data coming back, and it looks like it's working properly. I'll even go out and find that Philadelphia weather. and there it loads. Let's clear that out. Let's bring up some of those, and I like going to the New York weather here, and what you are noticing, I'm not getting that error. Every now and again there is one that takes just a little bit longer, but I'm not getting that error when it was loading weather data. Let's go back over to the log and take a look. There are errors happening in here, and this is the API, and you can see inside of here it's got a retry policy that it's going through and using when it makes requests out to the weather service, and it's still throwing that error that I put in here, random exception. I inserted that to kind of demonstrate this feature, and that error didn't come through to our application. So if we take a look at the other console, we can see here scrolling up, right, warning, guard seeing warning, poly execution attempt. It failed making the request. It got that error, that random execution error, and it retried and it got the right data and it presented it to us. So we are immediately seeing this resiliency, we are seeing this connectivity and information about what's happening, and we can start to correlate and see how things work together. Alright, now it's a little bit weird to try and connect data between the two of these, so that we can see a full setup what's actually happening in those requests. And it's also a little weird to have two applications here and two log files and bounce back and forth between them. In a larger scenario where I might have dozens of these services, these API endpoints, it's going to get a little hairy, it's going to get a little dicey, you know what I mean. We are going to end up playing this game with like files. You are going to have to go through and is it this one, is it that one, where did these things go? And as a developer, you don't want to waste your time with that. You want to be able to see the entire process of how these things occur and work with each other. So that's where we are going to start looking next. How does the dashboard help us with this? Okay, let's talk about the developer dashboard. Now that we have those smart defaults, let's start giving our developers a little bit of insight and the ability to peek into that without having to go through multiple log files and interact with things. The developer dashboard is going to give us those insights and also improve the manageability of your application system, so we don't have to perform multiple project startups. This way we can interact with and see our projects working in a nice manner. Right now, I want to clarify that Microsoft isn't trying to replace Aspire with Docker and Kubernetes. This is the .NET team attempting to provide an opinionated experience that makes it easier and reduces the amount of configuration needed to use those tools and services. In fact, .NET Aspire relies heavily on Docker and Kubernetes for some of the capabilities we have here. We've abstracted away some of those features to make it easier for folks to work with them, so that when you publish it becomes easier to manage as well. There are a number of things you need to configure manually with Kubernetes that just light up by default as part of .NET Aspire. So let's jump into a little more about the dashboard and what's great about the developer dashboard. Take a look at your entire application, see all of your projects running, and get deep visualization using OpenTelemetry to view the traces and see a complete stack of what's happening. The dashboard is built with Blazor, which means it uses .NET and our Fluent UI components, making it beautiful to look at, easy to work with, and perfect for managing all the components of your application system. I'm not just talking about an application, but your entire system. Right now we have an API project and a web project. It's more than just those two projects. It's the system that includes connecting them together. You can integrate the dashboard into your own projects in a couple of ways. If you want to run it as a standalone process, it's available as a container. You can find it at mcr.microsoft.com/.NET Aspire dashboard, and you are welcome to run the container using Docker or Podman, launching it whether you'd like. You can run it on your developer station, a home server, a Raspberry, a big server in the data center at your office. All of this is open source and anyone can connect to and use the dashboard along with the resources it makes available. You can also get the dashboard by using the Aspire app host. The app host is another template project I provide, allowing you to start up your application, connect all of those projects, and use C# code to declare the topology of your application system. That's important and it makes things much more interesting for us as developers. Let me explain because that's the orchestration capabilities we have in .NET Aspire. Okay, so you saw I had to go in Visual Studio. I've got this, write multiple projects, a startup dialog here that I can use to go and say, well, start my API and start my website and run them without debugging and with debugging and configure all of that stuff. And if I'm running in Visual Studio Code, I have a launch profile that looks like that says, well, go run all of these projects appropriately. And that's nice. That works. It's very hands-on. Do it yourself. I'm specifying all the things that I want to run here, but things can get a little dicey if maybe you have a database that you want to connect to and run. I like to run a developer instance of a Postgres database, and I put that inside of a container so that I can run it locally. When I'm not actively developing, I want to pause it. I want to shut down my databases and other developer tools in the background so I can go play some of my favorite games. Well, having gem running in a container makes it real easy for me to just say Docker desktop shut things down and I released all those resources and I can go play games. But I need to make sure when I come back and start my application that my database is running again. And a lot of folks have those database tools and services installed locally but having it run in a container. I can control when it starts and stops appropriately. So what we can do with Aspire is we can move some of that orchestration into C# code as part of the app host project. So you can immediately see the improvements of this compared to things like YAML that you might use for Docker Compose or a kubectl configuration file. I don't know about you, but when I'm coding with YAML, I prefer writing tabs inside my code files, and YAML doesn't use tabs, it uses a space. Well, I immediately get runtime error because I have the wrong white space in my file. Doesn't matter what syntax I'm using, you don't have the right white space. Once we get into syntax, then things start to become interesting. We are going to use C# to do this. And that means I can declare my services with code with a compiler that's going to enforce and check and give me hints that I'm writing code the correct way, that I'm adding on features to my application system the correct way. If you are using and writing code with Visual Studio or Visual Studio Code, you are even going to get GitHub Copilot suggestion configuration for you. It's fantastic. These are great ways that I can orchestrate and design how my application works. And here you see I'm just saying add project and I define what my project is. And I give that project a service name, API service and web front end. They then appear inside the dashboard like this. I have resources that appear and you can see these are two projects on line 1 and line 2, my API service and my web front end. And remember what I said about health checks. It's showing me that they are running in a healthy state right next to it. And I can also see the endpoints down there in the third to last column right here, right above my cursor. So now I've got insight. Now I can see exactly how my application is running and have those two services right next to each other inside my dashboard. So let's go set those up. Let's orchestrate and get this running on the dashboard. Okay, I'll go back over to Visual Studio. So we will stop the project and I'll go back over to Solution Explorer. Right now, I have my API, I have my weather hub, and I have my service defaults. So let's add the next piece of our Aspire solution. I'm going to add some Aspire templates and I will add the app host. I'll just call these app host to make it clear and a little bit easier to go through and find. It's .NET 8 and now I have my app host. So let's open Solution Explorer. it's right here, and there is a program.cs, and right now it's just going to run a distributed application. Set up a distributed application, build it, and run it. This is the entry point where we orchestrate and define how our application system runs. Our application system right now doesn't know about our API or our website, so let's add them into our app host so that it does know about them. And we do it the same way we do other .NET projects. We add references. Once again, I'll grab the Weather Hub project and drag it into app host, and you'll see it's going to add that project reference. I'll do the same thing with the API, drag and drop it on there. There are commands you can run at the command line that will do the same thing, but I'm in Visual Studio, so I'm going to do the drag and drop to make it a little bit easier to work with. Okay, so I have those sitting over here, and I want to define those two services for us to use on the dashboard. So let's add them. It's builder.add project. I'll use the generic syntax here, and I'll be able to specify projects. Notice there is a projects collection there. Check that out. Added a reference, and it generated this capability for me to step through and find these other projects. So let's add the API. I'm going to call this NWS for the National Weather Service API. Let's also add a project for the web application. There is my Weather Hub, and I'll just call it job because it's the website. I can call this whatever I want. This is an internal name that we can use to reference components of this application system elsewhere in the application system. So I can work with that. Let me start this. Actually, I don't have multiple projects that I need to start. I can just go in and say start the app host, and it will start up the dashboard application. It knows it needs to orchestrate these other projects, so it will start those. And as you see here, I get my console starting. I have one console that starts, and now that manages and handles all of them. Let's take a look. So there you go, you see it started app host. Okay, my application started. Here comes the dashboard. So welcome to the .NET Aspire dashboard. We have a bunch of different views here that we can use to take a look at the different parts of our project. There are the names we assigned: NWS API, job. They're available now, and it makes it easier for us to find and associate which project is which, and what they are doing for us. I can also click through and look at that specific endpoint for the application and still interact with it. I can do searches and use my application just the same way because I have those service defaults loaded. I'm getting the resiliency coming through. I can look at the logs the way I was before using the dashboard. My logs for the website have moved from a console window into the website, and I can see all my logs for my website here. I can flip over to the API and see all those logs here. All right. Now there is a lot more that we can do with this that will make it even more interesting for us to interact with. I can look at the traces here and see where there was an error, where it happened, and be able to view that information. There's the error, it was an exception. I can jump right into the logs and see that information, and the logs have filters and the ability to not just search for a term but search for different log level information. Jump right to what happened and get that information. As a developer, I can work with that and respond and do the mitigation steps that we want. Alright, we saw the console, we saw the traces, and now we are also getting metrics following through here. I can see the number of requests coming through. Some of these metrics automatically published for us for ASP.NET. They're already here. I see the requests coming through to the API loaded up and presented here automatically. Look at the duration being updated and presented on a screen for us. Okay, lots of cool stuff that makes it easier for you to interact with and see how these pieces interact with each other. But that's just one part of it. We are not done yet. Alright folks, in this video we've covered some pretty awesome topics in Dotted Aspire. First we talked about smart defaults, which give you those smart out-of-box settings so you don't have to configure everything manually. Then we explored the developer dashboard where you can visualize all your running projects in one place, and of course we checked out orchestration, which makes managing multiple projects smooth and hassle-free. Now in the next part of this video we are diving into service discovery and components. This is where we start connecting the dots between services and architecture, so everything communicates seamlessly. You are definitely going to want to stick around for that. Also, a quick note on my GitHub repository, it's private right now. If you want to clone the repository and explore the code, just drop your GitHub username in the comments below and I'll grant you access. That way you can check it out and follow along with all the examples and code we are working on. And of course, if you are enjoying the content, don't forget to like, subscribe and hit that bell icon so you stay updated whenever I post new videos. Thanks for watching and cheers.